Okay, so first of all, let's take a look at the schedule. We've never really deviated from this. I mean, a piece of a part might move over, perhaps. Um, uh, by the way, I got a tablet which I'm grateful for. All right, let me see if let's see. Look here. Okay, so where are we? We're here. Okay, so today, all right, October 27th. All right, so we're doing homework session chapter 4, and then the homework's gonna be due tomorrow on Wednesday. All right, so Wednesday. Oops. Okay, October 28. All right, so the homework will be due by then, by midnight, October 28, midnight. All right. And then as for the rest of the, what we're doing right now, okay, so you should be starting and continuing chapters 5 and 6. So chapters 5 and 6. 6.4 is 6.5 is not really 6.5. There's really no homework on, but chapters 5 and 6 that'll be due. I guess 2.5 weeks from now, Friday of this week, Friday of November 13th. Okay, Friday of November 13th. Okay, midnight. All right. So, any questions about the game plan? So we're not planning to adjust from this. Chapters 5 and 6 will be next. That's a much bigger and more involved assignment where work will be required. Okay, certainly on a fair number of problems. In fact, on section 5.2, I say there are various solutions, right? So I don't really give you any. Well, 5.2, basically, you're given the answers, right? You're given one side and the other side. You have to show me how to get from point A to point Z. So really, you have to show all the work, and I don't give you any guidance on those. Basically, on 5.2, for much of 5.2, I say, well, solutions will vary. And then on 5.3, when you're solving equations, yeah, normally there is some work to do. All right, but anyway, that's the game plan. All right, that's the game plan. Any questions? Any questions about the game plan? All right, yeah, go ahead and start putting questions in chat. And it might be a mix of me going in the order in chat, but also I might follow the order of the problems. Like, for example, if there's a section where one person is asking 4, then 3, then 2, I might go in the order 2, 3, 4, right? So it kind of depends on the situation. Okay, so for right now, let me, since there is some other noise going on, okay, so I'll mute people now, but of course, unmute yourself if you have something to say, actually something to say. It's not just noise, right? Okay, any questions so far? Any questions so far about the schedule? Okay, any questions so far about the schedule? All right, so we are recording. All right, again, if you want me to pause the recording, let me know and I'll pause the recording. All right. Okay, so are we ready to start? Okay, so go ahead and fill in problems in chat. All right, so I'll just move over here then. All right. So I'll go in chat here. Okay. Okay, we are recording. So anytime you want me to pause or stop recording, let me know. All right. So in the meantime, I'm going to go with chat. All right. So 4-5 number 9. All right. Yeah, that was a tricky one. So 4-5 number 9. All right. Okay, so let's start here. I'll bring in a whiteboard. See if the tablet helps. Again, very grateful for this thing. All right, so let's go to blue. All right, so number 9, 4.5, number 9, this one, right? Okay, 4.5, number 9, so it's going to be that one, graphing the sine. All right. Okay, so again, this is, let's see here. 4.5, number 9. All right. So again, so here's the given function here. All right. Now, the hard thing is that b is negative. All right. B is negative. So that's going to be a problem. All right. So we're going to start off by factoring a -1 at least from the argument. Okay. Now, you don't necessarily have to factor out GCFs or anything from the argument, but if b is negative, you should at least factor out a -1. All right. So h of x equals, all right, let's go 6 sine of bracket, okay, the opposite of. So when you factor, you divide both those terms in there by a -1, and you flip the signs. By the way, I'll move this thing here. All right. Okay, so we have the opposite of 2x plus 5 pi over 4. Okay, by the way, how well can I do my pi's here? Yeah, okay, gotta be kind of careful. All right. All right. All right. So 6 sine of the opposite of 2x plus 5 pi over 4 minus 3. Okay. So one of the things we're doing here is where we're factoring out a -1 factor. So that goes to positive. That goes to plus. All right. Okay. Questions so far? Let me know if there are any questions. And also, this tablet's working okay for you. Okay. Again, grateful for this thing. All right. Now, let's go to green here. All right. So this -1 factor, all right, what happens to it? Is sine even or odd? Is sine even or odd? Remember, only cosine and its reciprocal secant are even among the basic 4. This guy is odd. This guy's odd. So what happens to this -1 factor on the argument? What happens? This thing pops out. It pops out. All right. So then we get equals. So the -1 factor pops out. We get -6 sine of, okay, then these are both positive in here, 2x plus 5 pi over 4, all minus 3. All right. Question so far. We're exploiting the odd property of sine. And then it's a standard Picapia problem. All right. It's a standard Picapia problem. So I'll do the Picapia pieces in, let's go brown. All right. Picapia. This one I'll type in. All right. Picapia. All right. Starting with the pivot. And the pivot's the hardest part. Okay. Again, if you have any suggestions, you're in charge, right? You're in charge. You're my boss. So let me know if you'd like me to try anything different. Okay. But okay. So Picapia start with the first P, pivot. Now you might be going, there's so many P's here, right? But actually, I kind of like the fact that we have a couple P's here, because when you think pivot, the hard part is finding little p, the phase shift anyway. So the first two P's are really connected together anyway. The third P is for period. That's different. Okay. So let's start off with the pivot. Okay. Now, for D is normally easy to find, right? Because it's basically the constant piece over here. By the way, we know what the old problem is, right? So I know it's A through F, but I'm going to do the Picapia thing anyway. Okay. All right. So -3. All right. So the -3 is going to be the value for D. It's the loose constant term hanging out there. It's the vertical shift. Okay. And this corresponds to the fact that the pivot's going to go down 3 units from the origin for now. But wait, there's a phase shift, finding little p. And this is one of the big challenges. This is one of the harder parts of the problem. Okay. And you could say that I could have you show some work here if there is a phase shift. All right. Now, there are two ways of doing this. I'll show you both ways. All right. One way is to factor the argument. All right. So you have 2x plus 5 pi over 4. All right. You factor out a 2. You get x. I'm going fast because this is probably the less popular method. Okay. When you factor, you divide. When you divide by 2, you're multiplying by a half. So that's 5 pi over 8. So by the way, this method is probably the less popular one. That's why I'm doing it kind of fast. All right. So when you factor, you divide. When you divide by 2, you're multiplying by 1/2. All right. That's 5 pi over 8. But remember, that's basically 2 times the quantity x minus, negative 5 pi over 8. Okay, which means that the phase shift is going to be negative 5 pi over 8. All right, any questions so far? Questions so far? All right, but let me check something here. I'm gonna check something here. Checking the sensitivity here. All right. Okay, any questions so far? Questions so far? All right, so again, that's the less popular way of finding the pivot. The more popular way of finding the pivot, again, the goal here is to find P, the pivot, the phase shift, little p, all right? Okay, now the more popular way of doing it is to set this thing equal to 0. Actually, I'll do this in, do this in purple. This toolbar is getting in my way. Hold on a second. All right. Okay, so find P. Set the argument equal to 0. So you have 2x plus 5 pi over 4 equals 0. Okay. And then the idea is to solve for x. All right. So then you would subtract 5 pi over 4 from both sides. 2x equals negative 5 pi over 4. All right. And then again, there's this issue of dividing by 2. There's no way of avoiding that. So when you divide by 2, you're multiplying by a half. There might be an easier way of doing it. You're multiplying both sides by half, right? So 1/2 times negative 5 pi over 4 is negative 5 pi over 8 once again. So I'm getting that the phase shift is negative 5 pi over 8. Although you do have the right to add or subtract by the period, and sometimes that's an issue also, all right? That may come up later on. Okay, so for right now, again, this might change, but we could say that the pivot for now is negative 5 pi over 8. Actually, I think it will change. Negative 5 pi over 8, comma, D, which is negative 3. I will accept this as the pivot, but I believe I use a different value for P, which I'll explain in just a minute. All right, now, are there any questions about the work I have so far? All right, because again, the most work that's involved here, aside from computing the x coordinates on the frame, is finding the phase shift. So sometimes finding the phase shift is a more involved part of the problem. Any questions so far? Any questions so far? Okay. All right. So I'm going to go ahead and open another page here.
I have a question on the because I asked for this problem
Sure.
because I sent you an email asking if I was doing it right, and you told me to look at the frame method.
Oh, you're
And
asking about number 2, right?
yeah, but like I think the same thing applies to this, right? To find like the other values
Oh,
that like
yeah.
the other x values.
Right.
Is there an easier way to do that? Because it was taking me a long time to do it for all of them.
Right. Oh, yeah. I'm going to use the frame method again. The point is that this is one of the harder ones, right? Because first we had to prep this thing, right? We had to prep this thing because B was negative, right? So we had to prep it.
Yeah.
And then again, all this work here, and again, you don't have to do both parts. I'm showing you 2 methods, the factoring method and the set equal to 0 and solve for x method. The factoring method is more consistent with our concepts of translations from back in chapter 1. But for all practical purposes, I like method 2. I think students like method 2, right? Set this equal to 0, solve for x. Basically, what value for x will produce an argument of 0, and we associate the phase shift, the x coordinate of the pivot, with the value for x that makes this equal to 0. Well, right? Basically, we want to know when the argument equals 0. We want to know when the argument equals 0. That's the idea. That's why this works. Okay, and as you can see, we did the same steps over here, basically, right? Where we have a sign flip, we're dividing by 2. So that's one way of getting this phase shift, although this is one of infinitely many phase shifts that would work. I believe I used 3 pi over 8, which is actually nicer, and I'm going to explain that in just a minute. Okay, yes, this is a good involved problem. If you get this, you can graph anything sine or cosine, basically, I feel. All right, one moment, by the way, one moment. Wait. All right, sometimes I chat with people. Okay, so okay, so anything else? Any questions in chat so far? Right? Because again, this is a big part of a big part of the battle, actually. Right? Find the phase shift. Okay. Now we're not done yet. we're only about a third done, really. Okay. The first letter, Picapia, right? We've only done P, and even then, I'm going to change that value for the phase shift because there's a better one. All right. So next, let's do. Let's see here. All right. Next, let's do the cycle shape. All right. So what's going on here? So we have here sine. All right. Now, remember, if B's negative, you got to take care of that. I'm focusing on this guy here. All right. So for all practical purposes, sometimes the trackpad works, sometimes the mouse works, sometimes the tablet works. Okay. So, all right. Generally speaking, the mouse is better than the trackpad, at least. All right. Okay. So I'm going to focus on graphing y equals that. All right. Now, at this stage, B is positive. We want B to be positive, right? But in order to make B positive, we had to make A negative, right? A is now negative 6. A is now negative 6. The new A is negative 6, which is a negative number. So if you have sine, right? If you have sine, and if A is negative, then that's going to be the good evening graph, right? Where the graph starts at the midpoint, inflection point, goes down and then up. Okay, it's the good evening graph. That's for sine where A is negative. All right, that's a cycle shape. The A is for amplitude. And sine and cosine do have amplitude. The others don't, but sine and cosine do in fact have a bona fide amplitude. Now the amplitude is going to be the absolute value of A. Amplitude is always positive, right? So it's going to be the absolute value of A, which is the absolute value of -6, which is +6. Okay, we're going to need that too. So we're going to need the cycle shape, and we're going to need the amplitude. All right, next is period. Okay, next is a period. Okay, now for the period, okay, let's see here. For the period, now remember for period, it's going to be 2 pi over the absolute value of b, but since we're ensuring that b is positive, I'll just say 2 pi over 2, right? Because b is positive, right? And we get pi here. So the period is very nice. It's pi. Now I'm going to go back here now, all right? Now, -5 pi over 8, I'll accept any horizontal shift that's appropriate. If you want to stick with -5 pi over 8, that's fine, although you might not get what I get in my answer sheet, okay? Because here's the thing. You can get a better phase shift. And in fact, some books define the phase shift to be the horizontal shift, the appropriate horizontal shift that is closest to 0. So in that sense, you can make this better. If you add pi to this thing, right? If you add pi to this thing, what happens? You get -5 pi, -5 pi over 8 plus pi, which is 8 pi over 8, right? 1 pi is 8 pi over 8. I know that many students freak out at that. That's why the x coordinates are so tricky. -5 pi over 8 plus 8 pi over 8, which is pi, right, is 3 pi over 8. Okay. And maybe in my answer sheet, I may have used the 3 pi over 8 instead of 5. Whoops. Okay. 3 pi over 8, I may have used instead of -5 pi over 8 as a phase shift, because 3 pi over 8 technically is a better phase shift. It's quote unquote the phase shift. It's the phase shift because it's closer to 0. Okay, it's a better phase shift because it's closer to 0. Remember, if you take this value for little p we got, -5 pi over 8, okay, which we computed correctly, all right? Now, that's an appropriate horizontal shift. I'm willing to call it a phase shift. You can use it. However, some books define the phase shift to be the horizontal shift, the appropriate one, that's closest to 0. So some books may say, well, the period's pi. If you add pi, you get 3 pi over 8. That's closer to 0. That's actually the better phase shift. And some books call it the phase shift. On the homework, I'll accept either. Okay. Although, let me look at my answer sheet. Which one did I accept? Which one did I have on my answer sheet? Oh, okay. So I see here that I did use the -5 pi over 8. But in part D, when I asked for the phase shift, I put here 3 pi over 8 because I want to make this comment, okay? But on D, I ask, what is the phase shift? I'll accept either answer, okay? However, 3 pi over 8 is more appropriate because it's closer to 0, all right? Bear in mind, I could start my cycle at -5 pi over 8, as I do here, or a lot of books would have started with 3 pi over 8, okay, as their phase shift, and they would have started their cycle there. All right, and if you did that, that's fine. Some books would prefer that with 3 pi over 8, which is the more appropriate phase shift. Wow. Okay. Okay. So I'll answer A through F in just a moment after I finish graphing. All right. Questions so far about what I'm getting at here. All right. So because the period is pi, I can improve the phase shift, get a better phase shift, 3 pi over 8, because that's closer to 0. However, I'll accept either. Okay. There are infinitely many values for little p that'll work. 3 pi over 8 is technically the best one, although I use this in the answers. All right. Increment, which is my phrase, by the way. It's the quarter widths. The increment. Increment's my phrase, but you always take a quarter. All right. So the increment is going to be, all right, a quarter of pi, the period, which is pi over 4. All right, and that's really what we're going to use when we construct the frame. The period is used to find the increment, and in the homework I asked for what's the period. That's the answer to part C, right? What's the period? It is pi. No ifs, ands, or buts. The period is pi. Period. Okay, it is pi. All right, the phase shift you can argue, but the period is pi. Okay, we use that to find the increment, but we're not going to use that as much when constructing the actual frame. It's more for a check, because the increment is key, okay, because we want those quarter points. And finally, the capia, right? I added that to my type notes. The axes, don't forget them. Don't forget the axes and to label them. All right. So here's our cast of characters. I haven't even done any graphing yet. This is our cast of characters. Our pivot, P comma D. D is certainly -3. That's in the bank. Little p, there are infinitely many possible answers. I use -5 pi over 8, but some books might prefer 3 pi over 8. It's closer to 0. I got that by adding the period, pi. Cycle shape, the Canadian graph. Amplitude is 6. Period is pi. Increment is pi over 4. Okay. The choice of cycle shape, that's standard if you're basing on the pivot. So that's basically set in stone. These parts here are definitely set in stone. Okay, all books would agree that these 4 are what they are here. All right. The cycle shape might be slightly controversial. The phase shift is definitely controversial. D is not. All right. Are there any questions? Any questions before I actually graph this thing? I have the cast of characters. I have the ingredients. Are we ready to graph this thing? All right.
I have a question.
Go for it.
So the little p, the -5 pi over 8, so that's the leftmost x-axis on the graph, like no matter what?
Okay. Unless it's tangent. All right. So the left center point I call the pivot for all 6 trig functions except tangent. Remember that when we build the basic tangent snake, right? The basic, well, I'll do this first. Tangent is the one guy who's different. Tangent is different. That's 4.6, all right? Because the basic tangent cycle looks like this, right? VA here, VA here. This is our classic cycle for tangent where A is positive, okay? Now the pivot we associate with the origin, but here the pivot is in the smack dab center. So for the tangent, the pivot is at the center. However, for the other 5, including cotangent, the pivot, which used to be the origin, is going to correspond to the left center. So you're correct. Bottom line is, for sine, -5 pi over 8, my choice for the phase shift, okay, that's going to be the leftmost value for x. However, I know why you might have gotten confused. If you make the phase shift 3 pi over 8, then the 3 pi over 8 would be here.
Okay, that makes sense.
Right. So let me go ahead and if you choose the phase shift to be 3 pi over 8, then 3 pi over 8 would be your left x coordinate, and then you're going to get a bunch of positive values here. So of course, students had the right to start here because many books would have started here. Books may prefer 3 pi over 8 as your phase shift, in which case you would have gotten this cycle, right? Which would have been totally okay, but you might have wanted Desmos to check, right? Okay, but the way I'm doing it, yes, the phase shift is the left. The phase shift will be the leftmost number unless you have tangent. Then I tend to put it in the smack dab center. All right. Okay. So in fact, while we're at it, instead of making a mess of things, I'm just going to explain my picture here because you know, whether it's trackpad, mouse, or tablet, I'm going to make it a messy picture. So I think Mathematica is more trustworthy. Okay, and I'm going to start with the question, right? Okay, so I chose as my value for p -5 pi over 8, okay, which is appropriate. That's the leftmost number over here. However, as we said, some books prefer 3 pi over 8 as the phase shift. And in fact, technically, that was the answer I offered for part D, although I would accept either, all right, this or the 3 pi over 8. Okay, I chose -5 pi over 8. I'll put that at the leftmost grid line, all right? And then I add the increment. I add the increment. By the way, ironically, I'm starting with the x-coordinates first. A lot of students do that later because it's the harder part, but let's get straight to it. Here's a phase shift, all right? This is the hardest part of the problem, all right? Okay, and then we're gonna add the increment. The increment's pi over 4, all right? Increment's pi over 4. But wait a minute, negative 5 pi over 8 is in eighths. So folks, it might be actually better to think of the increment as 2 pi over 8, because we like to have that common denominator, all right? And the point of the increment is to add. The point is we want to add this thing, all right? So for all practical purposes, you want to add 2 pi over 8 to get each new grid line, the x-coordinate for each new grid line. So let's do the rhythm, okay? Fortunately here, this is easy in the sense that these are already simplified along the way, because otherwise, if it's not simplified, you have to simplify, right? Negative 5 pi over 8 plus 2 pi over 8 is negative 3 pi over 8, right? We're adding the increment. Negative 3 pi over 8 plus 2 pi over 8 is negative 1 pi over 8. Negative 1 pi over 8 plus 2 pi over 8 is positive 1 pi over 8. Positive 1 pi over 8 plus 2 pi over 8 is 3 pi over 8. Okay, so you don't have to show that as separate work. I trust that you can do that mentally, okay? So that's the thing. It's true that you don't have to show too much work on these problems, but as a student, you want to make sure that you can get these values, right? Get them at least mentally, right? So starting at the negative 5 pi over 8, all right, starting at the negative 5 pi over 8, you keep adding the increment, which is pi over 4, but since the common denominator is eighths, you actually want to think of the increment as 2 pi over 8. Add 2 pi over 8, 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 all right? Now you might be going, hey, where does the period come in, aside from getting the increment? You can check it. You can check by using the period. What is 3 pi over 8 minus negative 5 pi over 8? That's 3 pi over 8 plus 5 pi over 8. That's 8 pi over 8, or pi. That's an optional check. The right value, the rightmost value, the rightmost x-coordinate minus the leftmost x-coordinate must give you the period, which is the width of the cycle. So you can use the period to check. So what's the purpose of the period? To find the increment, so you can do these x-coordinates, and it's a check. The rightmost x-coordinate minus the leftmost x-coordinate is the period, which is pi. It's a nice check. All right. Okay, so, okay. So getting back to chat here. Yes, period for tangent and cotangent is pi over the absolute value of b. But remember, I'm assuming that b is positive. If b starts off negative, you really have to prep the thing so that b is positive anyway. All right. So once you make b positive, right, from appropriate algebra, okay, the period for tangent and cotangent is pi over b basically. For the others, whoops. Can I type? For the others, it's 2 pi over b, or 2 pi over absolute b. All right. Okay, so those are the x-coordinates. So let's go through the frame method again, all right? So the pivot, the pivot gets us the x-coordinate and the y-coordinate of the pivot. Okay, so here's the pivot here. The left center of the frame. Okay, which happens to be a point on the graph there. For cosine, for example, the pivot would not be a point on the cosine graph, because cosine either starts here or here. Okay, okay, so the pivot is at p comma d, right? So we know the coordinates of that left center point. It is a point on this sine graph, this sine cycle. Remember, it's this good morning, this good evening cycle. Good evening cycle. We hit this key point, this key point, this key point, this key point. Inflection point, min point, inflection point, where you change concavity, max point, inflection point. And you need to get the concavity right. For sine and cosine cycles, it's concave up below the midline, concave down above the midline. Make sure your concavity is correct. Please don't do something crooked like that. I want you to show concavity. Okay? It's not piecewise linear. All right? I want you to show the concavity. Concave up, below the midline, concave down, above the midline. Bear in mind that does switch for tangent and cotangent. All right, so we have the pivot there. We have the cycle shape. It's a good evening graph. Then we have amplitude, right? The amplitude is 6. Now, where does that come in? Aha. -3 plus 6. Too much purple. Go to green. -3 plus 6 is +3. -3 minus 6 is -9. I'm too thick. Yeah, sometimes that's better here. Hey, wait a minute. There we go. Okay, so -9 here, all right. Okay, so from D, right, this is D. From D, actually, the best thing is this and either mouse or tablet. Okay, okay, so D is this guy here, -3. You add 6 to get the top number here. You subtract 6 to get the bottom number here. All right. So for those of you who are like me, who are kind of going between a mouse and a tablet, I'm noticing that the mouse might be better for the small things like this, but definitely if you're writing like monsters, certainly, right, or fractions, then I think the tablet's better, right? I'm trying different styles. Okay, so you add 6 to get the top number, you subtract 6 to get the bottom number. Okay, that's how you get the y coordinates of the key quarter points. Okay, next, the period. Well, the period you can use as a check, right? This minus this is pi. And then the increment is a quarter of the period. We just did that, right? We did that to get the x coordinates. And I admit, that's the hardest part of the problem. The second hardest part is finding a good value for little p, right? In fact, there are different values that could work. -5 pi over 8 I used, but you could also use +3 pi over 8, which is closer to 0. And then you keep adding the increment to get these guys here. And don't forget, don't forget the axes, all right? So notice here, the equation of the x-axis is y equals 0, all right? Now, I'm not going to get a ruler out, but make sure that you put the x-axis between y equals -3 and y equals +3. In fact, it's right in the middle, all right? And put the x on the right end. Remember that you put the axis label on the positive end. Don't put the x over here. A lot of students do that. Put the x over on the right. Likewise, put the y on top of the y-axis. X equals 0 is the y-axis, and that's right in the middle between x equals -pi over 8 and x equals +pi over 8. But again, I'm not going to get a ruler. Just make sure it's in between these two grid lines here. Going to chat. Let's see. Oh, yeah. So yeah, I got a tablet, which I'm very grateful for. All right. But that's the thing. I mean, there are different modalities, right? I mean, the trackpad is good for basic mouse control. The mouse is good for, basic things like +6, -6. And I think, you know what? This tablet would have been great for the monsters, right? With like exponents and fractions and basically fractions. I think the tablet's better for fractions. All right. Anyway, so we're done. Now that was, hey, we spent a good like 40 minutes, but it was worth it. It was worth it, right? Because that's Picapia. And if you can do number 9, then you can basically do any sine or cosine guy. Just know which, what cycle to use, right? Because, if you have sine or cosine, if A is positive or negative, remember, I'm assuming B is positive by that point, right? But yeah, 4.5, number 9, one of our hardest, if not the hardest. Was that the last one? Yeah, it was the last one. Oh, by the way, let's answer the question. Well, I did A, right? We did, well, yeah, I showed you my, no fair to copy paste my answer, but okay, here's A, right? So I've graphed one cycle complete with the axes. Don't forget the axes, label them on the positive edges, positive directions. Okay, now the answers, the actual answers, all right? The amplitude was 6. All right. The period was pi. So yes, you use the period to answer my question. All right. Now, see, the thing is, I don't ask for the increment because that's not an official term, but really it's the increment that you use that you keep adding to get the x coordinates for the vertical grid lines. Okay, the phase shift, different possible answers, right? Because for my calculations, I got negative 5 pi over 8 for my calculations, and I'll accept that. But I'll also accept 3 pi over 8. Because most books actually would have preferred that because it's closer to 0, all right? And it's legitimate because you can take this value and add the period. All right, you can add or subtract the period any integer number of times. What's the domain? All real numbers. I think that's another one where, yeah, there, easy. Some things the tablet makes a lot easier. R, right? Basically, anytime you have a sine or cosine guy of this form, number times sine or cosine, a linear function of like x in here, and then a constant term, the domain will be all real numbers because you don't have x in the denominator, right? You don't have like a square root or anything. You don't have the square root of x. You don't have the square root of x. So you don't have those domain issues for x, okay? If you have the square root of 3, that's fine. That's a constant, okay? Of course, if you have 1/2, that's fine. That's a constant. But if you have x in the denominator, then you're going to have domain issues. If you have the square root of x, you have domain issues. Something of this format where you have sine or cosine, there are no domain problems. Now, if you have tangent, cotangent, secant, or cosecant, then yeah, you're going to have domain problems because of the trig. What's the range? You won't know until you graph a cycle. What's the range? It's the set of y coordinates from here to here. So the range is the closed interval from -9 to 3. So for sine and cosine, the range is the closed interval from the bottom y coordinate to the top y coordinate. And my answer sheet verifies that, right? Yeah, my answer's right here. Okay, amplitude was 6, period was pi. The phase shift, I'll accept -5 pi over 8, but 3 pi over 8 may be preferable. You can add the period, and that's closer to 0, actually. Some books call that the phase shift. All right, domains all reals, and or interval form's fine. Range is that. Remember, it's the lesser number on the left, greater number on the right. So although we spent like 45 minutes on this Picapia problem, it was worth it. I don't think I wasted your time. This was the best, most solid Picapia problem. So, folks, if you had any other questions about 4.5, I encourage you to pause, try to do it on your own, right? And then get back to me later tonight. All right. Any more questions here? You can see why I saved these. I'm saving these. Okay. By the way, the tablet's great in the sense that it'll save everything. So yeah, by using the tablet, I get the same functionality as if I use markup. So basically, the tablet's like a mouse. Basically, it's like a pen mouse. It's almost like a pen mouse. So yeah. All right. Okay, 459. So if you have any follow-ups, I'm going to keep these. All right. 475K. All right. I'm so afraid to move on because it's like if someone has a question, it's like, I got to go back and get in the mindset. Okay. 475K. It sounds like Battleship. I know. 475K. Yeah. These are answer only, but they're hard, aren't they? So if you ever take a test on this stuff, take a minute to think. Okay. In fact, on 5K, I'll be honest. When I first did the answer key, the first semester I used my homework, I think I got this wrong. All right. Okay, here we go. Inverse tangent of 2 pi over 3. Okay, now here's the deal. 2 pi over 3 asks inverse tangent, am I in your range? Am I in your range? Arctangent. arctangent says, well, let's see now. My range looks like this, the open interval from negative pi over 2 to pi over 2. You, my friend, well, you're not so much my friend. You're outside of that. You're a quadrant 2 angle. And I know that the angles in my range are either it's either 0 or it's either quadrant 1 or quadrant 4. So sorry, buddy. Answer is no. And then we see I have a sad face. Because many of you may have thought, hey, is the answer 2 pi over 3? No, because inverse tangent is only allowed to spit out undefined or a value in the range. A value in the range. All right. So now this is not quadrantal. I'm looking for the brother with the same tangent value. All right. So I'll frame it this way. Okay. So we have here the unit circle. All right. I want to find in blue, I want to find the brother angle with the same tangent value that's in the range here. But be careful. What sign is tangent in quadrant 2? All students, sine and cosecant are positive, but tangent and cotangent are negative. More easily, I associate quadrant 2 with negative slopes. Now, what other quadrant is associated with negative slopes? It's not quadrant 1. It's quadrant 4. Okay, I know you're used to thinking in terms of like sine and inverse sine, right? If this were an inverse sine problem, I tend to look at quadrant 1. But this is an inverse tangent problem. Hey, I'm looking for a brother that has the same tangent value as this guy. Well, tangent is negative in quadrant 2 and 4. The brother I want looks like this. And who's the brother I want in quadrant 4 who's in the range? I want a guy who's slightly negative. The answer is negative pi over 3. Right? I'm looking at that denominator. I know that pi over 3 is the reference angle for the guy I ultimately want. By symmetry, here's my answer. Again, I got this wrong, I think, the first time I tried it.
So for all of these problems, do we have to show work on them? Because I'm just confused on how you would do that for all of them. Or would you just do it like you just did, like show the axis and stuff?
You know what? Let me take a quick scan through here.
Not for those ones, for number 6, like all the ones on number 6.
Yeah, but I'm kind of looking at the whole homework assignment.
I mean 5, not 6.
Yeah. Let me look at kind of browse through the whole homework assignment here. That's a good question because my usual answer is do solutions like I do in the notes. The problem is that in chapter 4, it's like so much of this is mental. You could do answer only, and a lot of things I talked about, just discussing the concept in the class. So yeah, it's ironic for chapter 4. It's kind of hard to say what work to show. Well, certainly here, like for the word problems, I want to see the model triangle, right?
Yeah.
And for this, I would like to see at least a unit circle or computations. Okay.
Yeah, I saw you did one of those problems on one of the other question videos.
Okay.
I was just wondering for all the 5 questions for 5 on this section.
Yeah, okay. I'll say this. I'm okay with answer only, although for your benefit as a student, I think it'd be good for you to write little notes for you as a student, because the idea is that I hope that you keep your homework assignments. That's good, solid work. I hope you're keeping a binder, right? And you're going to want to look back at this stuff, and you're going to go, wait, why is that the answer? So just as a student who wants to keep this as your work, and you're going to want to keep this stuff, I would encourage you to jot notes for yourself. That's just as a study tool and a recording tool for yourself. Okay, but I'll accept answer only for 5. Okay, in fact, I'll write that down. My promises, 475, answer only. Okay. Although it would have been fair for me to say, show me the kind of thought process like I showed in the notes. But the thing is, a lot of these are just answer only, or you can think of the brother very quickly. In fact, the whole point of the whole brother shortcut is so that you can think of the answer quickly, right? That's the whole point of the brother shortcut. So yeah, on here, answer only. Although when in doubt, show work. I want to say that. When in doubt, show some work, because that's good for you. You know, yeah. If you have questions, you can email me. And if I have a problem with showing work, I might take off like a point or something. I won't be too harsh. Okay. So I understand. It's a good time for students to ask me, what work do you want us to show? That's true for homework and exams, right? It's a good question to ask. I'll be reasonable, and I won't harm people too much for not showing work. Although, except maybe for the word problems, I want you to show me the model, right? Show me the right. Come on, you got to show me the triangles. You got to show me at least triangles for the labeled triangles for the word problems. Come on. All right. Any more questions about showing work? Because that's a good question, and even have to kind of think about it. What work do I want to have them show? Definitely for word problems, show me the right triangle models, okay? And again, for your benefit, wherever you think work is appropriate, like the ones I pointed at, like these here, right? Solving these equations. I'm kind of going back and forth in my mind, but in any case, you're going to want to show work for your future reference, right? Like either a unit circle or showing the computations, right? Did you add pi or whatever, right? Okay, so I reserve the right to ask for work here, okay? Because again, unit circle or showing computations. So 7, maybe work. Okay, so I have notes on what work to look for. All right. So again, I'm chatting with some students from time to time. Oh, okay. Let's see. Okay. Okay. All right. So let me go in chronological order. I've only done the part 2 so far. Okay. So 4-2, the 4-2 block number 5. All right. Okay. 4-2 block number 5. Is this one right? No, no, no. Yeah. 4.2 is here. Number 5. I know it's like Battleship. All right. Yes, yes. I had many questions about this. Okay, now it's true that you could use Sohcahtoa, but the idea here was to exploit the properties of the special triangles. Notice here, it's a 30, 60, 90 degree special triangle, okay? So I'll go ahead and work out both parts A and B, where you find A and C. That's confusing, okay? B is 4 meters. All right. So here's the idea. And I think here, this is where the, I think the tablet may be helpful here. All right, so what is our, I'll type something first. What is our basic 30, 60, 90 degree right triangle? All right. Yeah, this is where the tablet can really help. All right. All right. So here is your basic 30, 60, 90. And in fact, I'm going to follow. So the shortest side is going to be facing the 30 degree angle. Okay. So I'm going to put the 30 degree angle. Oops. Over here. Right. 60 degree angle over here. All right. So once again, the shortest side is the vertical line segment. Okay. 1 meter, let's say. So here is like 1 meter. All right. The medium side is how many times as long? The square root of 3, right? Which is about 1.7. It's the medium side. The medium length faces the medium angle. The right angle, the largest angle, faces the hypotenuse, the longest side, which is like 2 meters. All right. So the basic 30, 60, 90 degree triangle has these. And these are the, it's like the proportions, right? 1 to root 3 to 2. Shortest side, medium side, longest side. This triangle here is similar to this triangle here. The proportions are the same, right? The sine of 30 degrees is always 1/2. The shortest side is always half the length of the hypotenuse. Likewise over here, A must be half of C. The shortest side must be half of the hypotenuse. half as long as the hypotenuse, because the proportions have to be the same as for this basic 30, 60, 90 over here. But this is really tricky because I'm giving you the medium side. I'm giving you basically this guy's analog over here. So what's going on? How do I get from the medium side to the shortest side? Well, over here. How do we get from the medium side to the shortest side over here? We divide by root 3. So to get to A here has to be 4 divided by root 3. Okay, but wait a minute. We don't like having these radicals down here that we can fix. Okay, see, if we had a root x, we can't really fix that. We can fix this thing by multiplying by root 3 over root 3, or rationalizing that denominator. It can be rationalized. So we get 4 root 3 over root 3 times root 3 is 3. That's the whole point, right? And technically, it was 4 meters up here, right? So it's this in meters, okay? So if this is 4 meters, then little a has to be 4 root 3 over 3 meters. By the way, the tablet was great for that. Lots of fractions here, right? And I am right? Yeah. Okay, so little a is 4 root 3 over 3 meters. Okay, so how do I get to there? Again, the medium on this kind of triangle, the medium side is always root 3 times as long as the shortest side. So to get from here to here, you divide by root 3. Okay, you can also look at it in terms of proportions, right? Think of it as this proportion problem. Okay, so it's like 1 is to root 3 as a is to 4, or 4 meters. Okay, 1 is to root 3 as a is to 4 meters. And then you solve for a. You can think of it as a proportions problem. Multiply by 4 meters, you get that. Okay, so you can set up a proportion. You can set it up as a proportions problem, like the whole cross multiplying thing, right? Okay, we're not quite done yet. Okay, let me go to green, dark green now. All right. Well, once again, how do we get from the shortest side to the hypotenuse? Well, to get from the shortest side to the hypotenuse, for this kind of triangle, the hypotenuse is always twice as long, right? What's twice 4 root 3 over 3 meters? Well, twice is 8 root 3 over 3 meters. So it's twice this guy. Twice. Because again, the side lengths are in the same proportions as for this guy. All right. So that's A. Oh, okay, and then that's C. That's C. 8 root 3 over 3 meters. Yep. Right. All right. Questions? Because I know a lot of people have questions about this. It's like, oh my gosh, is this a Sohcahtoa problem? You could make it a Sohcahtoa problem, but remember, the point was to use the special triangles, which is what the Sohcahtoa table is based off of, right? Okay. So a lot of people wanted that one. I know. Okay, 4.8 number 4. Sounds like a word problem, which I'm sure a lot of people wanted. All right. Oh yeah. Oh yeah. Okay. Yeah, pretty much everyone wanted this one. So I think I'm gonna get another whiteboard here. All right. Okay, so let's draw this in. I think blue is good. Blue is good. All right. So we're doing 4.8 number 4. All right. A bird. in the notes, I may have used a plane because we care more about planes, right, than birds. But okay, a bird is flying at an altitude of 1,500 feet over a flat desert. Okay, flat desert. I'm very precise with my problems. It's a flat desert. It's not on an incline. It's not a hill or a mountain. Okay, it's a flat desert, horizontal. Okay, now altitude. What does altitude mean? Okay, so here's the bird. I'm not even going to try to draw a bird. You'll laugh at me. Okay, more. You'll laugh at me more. All right, here's the bird. This is the altitude. It's not this, right? It's the straight vertical altitude. So this here is 1,500 feet. Okay. Okay. So right off the bat, right? A lot of people don't know what the altitude is. The altitude is the straight vertical distance from the horizontal, 1,500 feet. This makes a right angle. Right. Now the observer, okay, this is not the scale, but the observer is over here. All right. Now the bird is flying on a line that takes it directly over an observer. So I'm doing this other side of the rectangle. All right. Who's lying on the ground. So that's why I don't count your height. All right. If the angle, okay, part A, because these are different pictures here. This is for part A. If the angle of elevation from the observer to the bird is 51 degrees. All right, so 51 degrees here. Okay, yeah, the tablet's really shining for the right triangle models. Today was the perfect day for me to really use the tablet. Okay, what is the distance from the observer to the bird? Okay, so the thing you want to know is, I'll call this X. Okay, you could also call it C. I'll go ahead and call it X. All right, so I want to know this straight line distance between the observer and the bird. That's going to be the hypotenuse. So right now, right, that's very informative to a lot of you because you didn't know how to label the triangle. In fact, when I grade these kinds of problems on exams, the single biggest mistake is that people don't know what to label with what, right? A lot of people put the 1,500 feet there because they don't understand what the altitude is. It's the height. It's the height of the bird, okay? It's this. All right, so off the bat, some of you might be able to do this right now, all right? But let's go ahead and solve this. So what's the distance from the observer to the bird? Round off your answer to the nearest foot. All right, so, all right, what do I know? I'll do this in green. What do I know? I know the angle. I know the opposite side, O. I know the hypotenuse, H, right? What famous trig function relates opposite side and hypotenuse? I'm thinking sine, more than cosecant. I'm thinking sine. So sine of 51 degrees is, opposite is 1,500 feet, although you don't have to put the unit till the end. In physics and chemistry, they tend to carry the units, over x. Oh, okay. Here's another reason why it's hard. It's easier if the x is on top. Here, the x is on bottom. That's okay. Multiply both sides by x. So here's the deal. I'm going to multiply both sides by x, and I'm going to divide both sides by the sine guy. So do you believe that? I multiply both sides by x, and then I divide both sides by sine of 51 degrees. And in fact, this is an exact form for the answer. But I say here, I want you to round off to the nearest foot. And this should be, whoops. (1,930 feet). Is that what you're getting? 1,930 feet. And then technically, I'm not going to grade on this, but in this age of Common Core, I'm supposed to encourage this. What is the distance? Okay, the bird is about 1,930 feet from the observer. In the days of Common Core, we're supposed to write our final answer in terms of proper sentences, if possible. Will I grade on that? Probably not, but I'd encourage you to do that. Okay. So let me right. In general, is there anything I can clarify on this? Again, maybe I should put in this missing step here. I was being a little lazy.
Are
So,
we allowed to solve it with like the law of signs like differently?
oh, a lot of students do that because they remember the law of signs. I'll
Yeah, I
accept
did
that.
that.
Yeah, I'll
Okay.
accept that because this is 90 degrees, right?
Yeah.
Yeah. But if you think about it, here's what happens. In fact, this is exactly what happens. Take a look at this. 1,500 feet over sine of 51 degrees equals x over sine of 90 degrees. But hey, what is the sine of 90 degrees? It
One.
is 1.
Yes, that's the same thing basically.
So does the law of sines work? Yes, it works, but you don't even have to think that. You don't even have to do that. You can do Sohcahtoa. Although for some people, the law of sines may be easier. Right. So I'll put it this way. I won't mark you wrong. I think it's great you know the law of sines. We'll review in chapter 6. But I think it's good to understand the Sohcahtoa approach as well. So I would encourage you to take that perspective as well. Okay. In terms of showing work, that's fine. You can show the law of sines. That's fine. All right. A question in chat. So if I'm pausing, it means I'm looking at the chat. Let's see. I'm not asleep. Oh yeah. Drawing it is a pain, in the sense that that's where students mess up. They don't know what side to label what. What's the hypotenuse? Where are the legs? No, absolutely. I would say that 90% of the time, 90% of the errors that students make on this kind of problem is because of mislabeling. Okay, not labeling the correct side what, and basically you have to practice. In fact, it would not be unwise to go to like a trig book, or maybe a free one of those free OpenStax OER free open educational resources books online. Do some practice problems, right? Model the things. All right. Any further questions about this word problem? Again, I'll accept the law of signs. A lot of students like that, but as you see, it just degenerates down to what's really Sohcahtoa anyway. Also, I wanted to put in the missing step because I realized that some of you may have been confused from here to here. Here's the missing step. I multiply both sides by x. I know that sine of 51 degrees is the constant, but it's because I don't want you to think that sine of 51 degrees x, right? Because then people get confused where you're taking the sine of. This is safer so that we know for sure 51 degrees is the argument for sine equals the 1,500 feet. So if you want, you go from here to here, multiply both sides by x, and then you divide both sides by sine of 51 degrees. So in case you're wondering how you got from here to here. But of course, you don't have to put that. I'll accept from here to here. You should show some work. Show me the triangle, okay, and show me what you're doing. It could be the law of sines, but show me what you're doing.
Okay, and then for B, since the angle of elevation is no longer in play, is the hypotenuse value still the same for
The
B?
angle of elevation is what you want to find, right? Yeah.
Yeah.
So yeah. Okay, so that's a different picture. So that's worthwhile. Let's talk about it.
So does that x value stay the same, or do you use the law of sines
No, it's not
with
going to.
the 90-degree angle?
We could do this all sines. It'll be a different. It's not going to be 51 degrees. So here's the way that I would approach it. Again, you can use the law of sines, but here's the way I would approach it. Well, it's going to be a right triangle again. I can tell it's going to be a right triangle again. Although in chapter 6, they may not be right. Okay, so I'll do blue again. All right, so let's do the, just 1,700 feet. Oh, so that means the bird's kind of flying away from you. No. It was 1,930 feet. So no, the bird's flying towards you because in A, the bird is over 1,900 feet away from you. So the bird's closer here. So just for reference, it's going to be a bigger angle. We think it's going to be a bigger angle. Well, theta is unknown. Right angle. The bird still has an altitude of 1,500 feet. That does not change. That stays constant. And
okay, I see now.
By the way, in calculus, it's important to know see, in calculus, you do things like studying speeds and things like that, like rates of change. It's important to know what stays constant and what changes. In this problem, this altitude is constant, like a plane. Well, hopefully a plane's higher up than that, but over the desert, 1,500 feet. For a plane, I hope you're 50,000 feet up. But for a bird, the bird could be 1,500 feet up. Okay, that stays constant. But theta and x change with time, right? They change with time. And I'm telling you I'm telling you what x is now. X is now 1,700 feet. So I'm giving you the vertical leg and the hypotenuse, but it's hard for students to know what I'm talking about. Okay, certainly the hypotenuse is the longest side of the triangle. If you put the 1,500 feet here and the 1,700 feet here, you know for sure you're wrong because the hypotenuse has to be longer than either leg, right? So yeah, so basic observations like those can help. All right, once again, what trig function connects angle, opposite side, and hypotenuse? It's the same basic trig function, sine. But this time, we have to find the angle. It's acute, by the way. We know theta is acute. Well, I don't explicitly say that, but it's assumed that's acute, right? I mean, from the nature of the problem. There are different ways of drawing it. Okay, sine of theta equals opposite over hypotenuse. Well, you can reduce, right? I mean, this over this is just 15 over 17. All right. Remember, sine of theta, sine values have no unit because the feet guys cancel, right? Sine of theta has no unit. It's going to be 1,500 feet over 1,700 feet. That reduces to 15 over 17, pure number. So to compute this, what do you have to, what function do you use in your calculator? Theta is the what? We're looking for an angle. Theta is the inverse sine or arc sine of 15/17. So folks, for your work on number like 4B, I would like you to show me work like that, right? Show me the right triangle model, show me what you're doing. I would like you to show me work like this. I have the right to mark you down if you don't show me what you're doing here. Okay. So here's the benefit of coming to class. I will say this, folks. As far as work goes, let me take another quick scan here because I think I'm ready to make a judgment now. Let me take a quick scan here. Okay, now I think work helps on 1, but let's not worry about that for now. On 1 and 2 it helps, but
I've been able to show work on like all of them except for the inverses, which I was talking about before.
yeah. Well, work helps to figure out what the answers are, certainly. All right, here's a benefit of coming to class. I'm going to make the following declaration. If I grade anything, if I grade these problems, the only ones I'll grade on work will be number 7 on 4.7. That's this, right? Yeah, number 7 on 4.7, these guys, right? Or stuff on 4.8. So let's make it easier on you and me. Work that I could call you out on. 4.7, number 7, all those guys, and anything in 4.8. So I'll make that deal with you. Okay, the only way I'd mark you down for work is for 4.7, number 7, one of these guys. So show me work on these, definitely. And 4.8, show me work on these. Good to come to class. Then you can get me on the rules. And do that. As students, push me on that. Okay? Remind me. So professor, or what's your face, Ken, right? What ones do you want to show work on? And that'll force me to, you're going to put me in a corner, and then I'll say, okay, I'll only mark down on work for these, and I'll keep my promise. Okay, I take notes during these lessons. All right. You're kidding me. It's already 8:23. Time flies. I mean, I'm enjoying myself, actually, but I guess let's take a break. Let's take a common break. In the meantime, feel free to go ahead and put some more problems in the chat. But let's take a break. It's 8:24. So let's come back at 8:35. All right, remember to mute. Okay, so I'll put that up here, right? Mute. I'll pause now, and then I'll record. Okay, and I'll see you at 8:35. In the meantime, feel free to continue to put your problems in chat. Not your personal problems, but math problems. Personal problems you can do privately, I guess. Though I can't promise I'll be much help. Yeah, dump that person, whatever. All right. So let's pause the recording. All right. So welcome back. I'm continuing with the chat questions here, and where am I? Oh, I haven't done C yet. Okay, so C. Oh yeah. Oh, if I didn't even finish B yet. Okay, B. The answer to B was what? B was 61.9 degrees. Okay, is that right? Can you check that?
Yes, it's right.
Okay, inverse sine of 15.
60. It's 61.9, not
61.
16.
Yeah, 61. Right. Because it's a bigger angle. See, this is a good check, right? Because sort of common sense tells you that, see, this was when it was 1,930 feet, it was 51 degrees, right? The bird's closer. So common sense says that this should be a bigger angle. So if I had left it at 16.9 degrees, I hope that I should use my common sense and go, wait a minute, the angle should be bigger, right? And yeah. And that's right, inverse sine of 15/17 in degree mode. Okay, remember, for word problems, we tend to give answers in degree mode. And yes, in the days of Common Core, what the angle of elevation is, blah, blah, blah. Is that right? Yeah. the angle of elevation, I'll accept that. Well, I mean, I'm not going to grade you on the word part, but you should put a sentence. The angle of elevation is about 61.9 degrees. You put the degree symbol, right? Okay, and then C quickly. At noon, the bird's shadow is directly beneath the bird. Okay, so let's set up C. Okay, this is B. I better label this actually. So this is 4.84B. All right, and then can I do 4. Maybe just kind of set up 484C green. All right, so what's the deal with 484C?
Would it be the same thing, but with the hypotenuse being 250?
Let me move this up here. Let's see the distance of the bird shadow. Oh, okay. Actually, I think no, it's not hypotenuse. I think it's this actually. So let me So here's the observer. Here's the shadow. At noon, the bird's shadow is directly beneath the bird. The distance of the shadow from the eye is 250. This is 250 feet. The bottom leg. Find the new angle of elevation. So I would think that theta is pretty steep, right? Whoops. Yeah, 80.5 degrees. It's pretty steep. Yeah, that's not surprising. So it turns out the answer here will be 80.5 feet, 80.5 degrees. Right? 80.5. Yeah, 80.5 degrees. And why is that? Yeah, the bird is still 1,500 feet in altitude. That stays constant. That's the constant for A, B, and C. In a calculus problem, that would stay constant, right? What relates angle, opposite, and adjacent? Hey, folks, what basic trig function relates opposite, angle, and adjacent?
Tangent.
Tangent. Or cotangent. Let's go tangent. Tangent of theta is, if you reduce this, it's 1/5. Okay, well, it's going to be 1,500 feet over 250 feet. That's 6, isn't it? Isn't it just 6?
Yes.
Yeah. So you want the inverse tangent of 6. And that's legal. Remember, 6 is a slope. It's a steep slope. Okay. And apparently it's about 80.5 degrees. Is that right? Is the inverse tangent of 6 about 80.5 degrees?
Yeah.
Yeah. And again, your Common Core thing, the angle of elevation is about, I'm not going to grade on that, but you're supposed to write the sentence. The angle of elevation is about 80.5 degrees. But if you understand that the 250 feet is this bottom leg here, you see it's going to be a pretty steep angle. Yeah. Okay, so it's always keep your common sense in mind. Like for example, when I almost wrote 16.9 degrees, if I use my common sense going, wait a minute, it's a steep angle, not a flat angle, I would have caught that, I think. Yeah. All right. That's 4.8 in its full glory. All right, so yeah, no excuses. I mean, I'm showing you the work. I mean, if you show me what I'm showing you here, you don't even have to write the sentences, so I recommend it, right? Again, it's the days of Common Core. We're supposed to write these things with nice sentences. All right. Okay, any questions? We've done 4.8, number 4. Okay, it's being recorded, right? Yep. So you can review this. Any questions on 4.8 while I have this here? And I'm going to save these. All right. So 4.8.4, a good solid one. All right. I was actually worried. Are we going to have much to do today? Oh, yeah, we have a lot to do today. There's a lot to talk about. Okay, even though, yeah, answer only and all that for many of these. You want to understand it. Because if you don't understand this, you're not going to get 5. All right, so I think 464 was next. That's a private request, 464. Yeah. And someone else was asking for a 4.6. So let's do 4.64 next. Again, never take anything personally. If I'm missing something, don't take it personally. It's just that I'm just trying to figure out what's appropriate. Okay. Okay. So I think 4.64 will be next. If you think I forgot something, let me know. Don't take anything personally. I'm not dissing anyone. 4.64, and someone's asking for a 4.6 problem. All right. So, I like blue as my base color because red is too red alert. Okay. So, okay, 4.64. Okay. And by the way, seriously, if you want me to change formats, like if you prefer mouse, tablet, different stuff, because the tablet's smoother, but it might be too fast. So let me know if you want me to change the style. Okay, so yeah, this is another one where B is negative, so it's good to factor out a negative one for the argument. So let's go ahead and do that. All right, so let's see here, 4.64. All right, so first of all, f of x equals. Now you don't have to recopy it. I think it's nice to have that as a reference, but I won't recopy it. So 5 cotangent of, I think, well, let me go back here. The old sensitivity was better. All right. Okay, so 5 cotangent of, all right. So again, I'm going to factor -1 from the argument. So you have the opposite of. When you factor, you divide. When you divide both those terms in there by -1, okay, both the coefficients go to positive. The opposite of positive 4x plus, whoops, plus pi over 2. All minus 3. All right. Now, is cotangent even or odd? Well, remember, only cosine and secant are even. So this guy's odd. I'll put this in green. All right. Cotangent is an odd function. Most of them are, right? So what can I do with this -1 factor on the argument? This thing pops out. All right. So we apply the odd property. Okay, so we really want to graph y equals -5 cotangent of positive 4x plus pi over 2, all minus 3. All right. Any questions so far? Questions so far? Okay. And again, I can switch the input device from between mouse and tablet if you want me to write differently. All right. Well, I think it's good to analyze this as is. Okay, so I'm going to focus on this. So for all practical purposes, I want to graph y equals this over here. We want b to be positive. So b is 4, a is -5. All right. As it stands, the new a is -5. The new b is 4. All right. So let's go ahead and do a Picapia. And then I'll go over the details here. Okay, so let's go ahead and do Picapia. Picapia. All right. First P for pivot, which involves phase shift. I don't mind that the P's are kind of conflated because the pivot, the phase shift is the hardest part about the pivot. Pivot, especially the phase shift. So I don't mind that we have all these P's here. Because little p is the x-coordinate of the pivot. All right, so what's the pivot? The pivot is P comma D, where little p is the phase shift. Okay, it's one of the hardest parts of the problem. In general, the x-coordinates are the hardest part of the problem. The phase shift and the whole deal of adding the increment. By far, that's the hardest part of the problem, the x-coordinates. D is straightforward. D is -3. Okay, so D is -3. That's pretty straightforward. That's a downward shift of 3 units. All right, but the phase shift, that involves more work. Now, again, you could use the factoring method, but I think the solving the equation method is generally more useful here. Okay, it's a more popular. So we're going to solve the argument. We're going to set the argument 4x plus pi over 2 equals 0. I want to know the value of x that makes the argument equal to 0, because that's like our starting point. Okay, well, subtract pi over 2 from both sides. 4x equals negative pi over 2. All right, divide by 4. Now, here's the thing. I know that this is correct. Negative pi over 2 all over 4. But admittedly, this is very confusing for students, and I don't blame students for being confused. So it might be better to think of it this way. When you divide by 4, you're multiplying by what? You're multiplying by 1/4. Think of it as multiplying both sides by 1/4. So then you have x equals 1/4. Whoops. 1/4 of negative pi over 2. And then you multiply across. All right. X equals negative pi over 8. Okay, so I'm going to let that be my value for little p. And unless the period is super close to 0, I think that's the best phase shift we're going to get. In any event, I'll take any horizontal shift that's appropriate. Remember, you are allowed to add or subtract the period any integer number of times to try to get a nicer phase shift, but I think this phase shift is best. Oh, the C over B method. I think when you do that, isn't it opposite C over B? See, that's the thing. It's easy to forget the formula. Isn't it opposite C over B? Oh, it depends. Oh, I see. So, oh, okay. A student's raising a point privately, but I want to point out that there's some books that do this. Something like y equals a cotangent of, now, if it's bx minus c, all plus d, then it's true that the pivot or the phase shift is given by c over b, because that's the solution you get when you set that equal to 0 and solve. But the thing is, it's easy to forget that's a minus sign there. my objection is that this is easy to mess up. But if you want to use that formula, that's fine. And remember, as I said, I kind of hate saying this, but I'm not going to grade you on your work except for those last problems we discussed, right? The 477 and the 48. But I do want to discuss this issue. If you can remember this kind of format, you're right. Little p can be given by c over b, because if you set bx minus c equal to 0, the solution for x will be c over b. But my objection is that it's easy to forget that there's a minus sign there, for example. So if you remember, this is correct, but I'm wondering if you can remember that. Yeah, yeah. But again, that's the thing. Even I have to remember that, right? Um, it's that whole sign thing. The fact that the sign messes you up. This was the case all the way back with horizontal translations. And we're basically talking about a horizontal translation here. The sign can mess you up. You got to be careful with the sign. But if you can remember it's like this, that's fine. Still, as someone who tends to forget things, right? I tend to forget things, forget signs. I like to set the argument equal to 0 and solve, because that gives you the same thing. All right. Anyway, so methinks that the pivot, a good choice for the pivot will be, I better do this in like red or something. And I'll move the toolbar to where the caption should be. That's a good, yeah, that's a good habit. Move the toolbar to where the caption should be. That's a good habit. All right. So anyway, the phase shift should be negative pi over 8, we think. So then I think the, I think the PD should be negative pi over 8, comma, negative 3. So we're going southwest, down to the left. Okay, I'm answering C. C is negative pi over 8, I think. Let me get the answers. Oh, here are. Yeah, negative pi over 8, right. And that's the answer to C, negative pi over 8. Okay. Although notice that I guess you could have taken positive pi over 8 too. So these are both equally far away from 0. Maybe some books prefer pi over 8 because it's positive. Okay, but you could take negative pi over 8, or if you had gotten pi over 8, that would have been fine too. All right. So even if you had messed up the sign, although that's also by luck, because the period was what it was. So that'll be a bit by luck that the sign didn't matter. Anyway, the pivot, that was a hard part. Let's get another page. All right. I love text edit. Just screenshotting it and nice little whiteboard there. Okay, so next is cycle shape, right? Okay. All right, so what do we have here? We have cotangent. And remember, we're looking at this circle part here, right? B is positive, A is negative. So under the assumption that B is positive, okay, note that B is positive. I need that, all right? A is negative. Now, I know that with cotangent, you normally think falling snake, but that's if A is positive. If A is negative, you got the rising snake. Okay, so remember, you get the rising snake if you have tangent and A is positive, or if you have cotangent and A is negative. Cotangent, A is negative, that's a rising snake. All right, now I'm going to go ahead and, since my pictures are horrible, right? Okay, I'm going to go straight to the answer here. All right, so tic-tac-toe. You want to do the 3 rising points here, here, and here, with VAs at the edges. That's the way I normally frame tangent or cotangent. But for cotangent, the pivot is at the left center. Okay, the pivot is at negative pi over 8, negative 3, and it's the left center point. The pivot is over here at the left center. Okay, not the center. That'd be for tangent. All right. Although it so happens that the origin's pretty close to there in the end, as it turns out. Okay, anyway, any questions so far? Questions so far? Right.
I have a question.
Yeah, go ahead.
How do you find the asymptotes?
Oh, that's part of my frame. Okay, so as part of my framing method, for both tangent and cotangent, I put the asymptotes at the edges. Okay. Now for cotangent, the classic cotangent graph looks like this. I'll get the tablet. Okay, so for classic type, what does the classic basic cotangent graph look like? I mean, basic cotangent of x, right? What does that look like? All right, the basic cotangent of x graph looks like this. Okay, the frame here. Whoops, VAs at the edges, 0, pi, and it was a falling snake. This was a basic cycle for cotangent, basically, right? Okay, and the VAs were at the edges. Same thing over here. VAs are at the edges, right? But notice the origin in the basic cotangent graph, again, it was at the left center. The left center. Tangent's the only one where I put the pivot at the center because of the way the tangent's structured, the basic tangent graph. Okay. So yeah, for all tangent cotangent cycles, I like to put the VAs at the edges. All right. Okay. But if you do that for tangent, the pivot's in the center. All right. Any questions? Any questions? Okay, so we got the pivot, we got the cycle shape. It's a rising snake, concave down below the midline, concave up above the midline, because you're approaching the asymptotes. Okay, so instead of thinking in terms of concavity, you're approaching the asymptote. So you should be able to figure out it's concave up, approaching the VA here, concave down, approaching the VA like so. Okay, and it's symmetric. The cycle is symmetric about the center point. So we have the pivot, we have the cycle shape. All right, A for frame amplitude. Where am I? Okay, A for frame amplitude, because sine and cosine are the only two with actual amplitudes. The other guys have frame amplitudes. Amplitude of the frame. A for amplitude of the frame. Okay, so that's where we get the absolute value of A, the absolute value of -5 is +5. All right. But again, remember, these guys, we have a snake here, right? The snake itself does not correspond to an amplitude. The amplitude refers to the half height of the frame. It's the difference in the y coordinates between between successive quarter points. Okay, so the frame amplitude was 5, right? So the idea is that -3 plus 5 is 2. -3 minus 5 is -8. So you put the +5. You don't have to do this as work, but add 5 to get the 2, subtract 5 to get the -8. Right, and then you have all the y coordinates for these 3 key quarter points. And we also have the 2 VAs over here. Questions so far? Okay, so we got the pivot, we got the cycle shape. The frame amplitude helped us get the, see, this is D, right? D is -3. D is -3. From here, we add the frame amplitude to get the 2, subtract the frame amplitude to get the -8. All right. Now, the last P, in a way, it's a third P, right, is for period. Careful. For tangent and cotangent, careful. Pi over the absolute value of B, all right? By this stage, B is +4, right? I'll say it right here, pi over 4. It's pi over the absolute value of B, pi over 4. But wait. We more practically use the increment, what I call the increment. Don't look that up on Wikipedia. It's a general idea of adding something, right? Increment's a word. It's not a word you see that often in a trig book. The increment is always what fraction of the period? It's always, here's where the tablet comes in handy, fractions, it's always 1/4 of the period. Always, always, always. Always, always, always. 1/4 of pi over 4 is pi over 16. All right. And don't forget the axes. The A is for axes, coordinate axes. Don't forget them. Okay, and voila, Mathematica did this for me, all right? The hardest part is the x coordinates, right? The phase shift, little p. The phase shift, little p, is negative pi over 8 that goes on the left, right? Only tangent is center, center. For any other guy, it's left center. Negative pi over 8 goes on the left edge here. Okay. Although you could have done negative pi over 8 here and subtracted. That also gets you a cycle, right? But here's negative pi over 8, okay? And then you add the increment, right? But the increment is pi over 16. So we want the common denominator of 16. Negative pi over 8 is also known as negative 2 pi over 16. Right? 1/8 is 2/16. So negative 1/8 is negative 2/16. So negative 1/8 pi is negative 2/16 pi. Why am I doing this? Because now I have 16ths. I add the increment, which is pi over 16. Negative 2 pi over 16 plus 1 pi over 16 is negative pi over 16. Negative pi over 16 plus pi over 16 is, hey, we get lucky, 0. And then you can either keep adding or just use symmetry, right? You can use symmetry about 0. Negative pi over 16 goes to pi over 16. Negative pi over 8 goes to pi over 8. Because remember, this snake here is symmetric about the center point. Or you could just add. 0 plus pi over 16 is pi over 16. Pi over 16 plus pi over 16 is 2 pi over 16, also known as pi over 8. All right, where does the period come in? Pi over 8. I'll do this in blue. Where does the period come in? Pi over 8 minus negative 2 pi over 8 is 2 pi over 8, or pi over 4. That is the period. It's a check. There are 3 reasons why we care about the period. So you can get the increment, so you can check if you wish, and to answer my homework problem. I think I asked for that, right? What's the period? Yeah, period. It's the answer to B. The period is pi over 4. That's the answer to B. See, B is pi over 4. That's the period. Pi over 4 is the period. The phase shift can be said to be negative pi over 8. Although it turns out that pi over 8 also works, right? Notice that another cycle starts from there. Positive pi over 8 also would have worked. Or you would technically get that by taking this value and adding the period. Then you get pi over 8. Like I said, you can add or subtract the period any integer number of times, and you can also get an appropriate phase shift. So basically, any phase shift here that corresponds to a VA. Right? That works for cotangent. That works for cotangent. For tangent, the pivot corresponds to the center. And remember that for cosecant and secant, remember that you have VAs like in the mix, right, between the up use and down use. All right. Oh, yes, good night. Some of you have to go. Good night. Yes, it's 9:03, but I will go on. Yeah, I had to eat my words. Before, I used to say, yeah, the chapter 4 problems didn't take so long. No, if you're doing a Picapia problem and you want to do it well, it does take time. I mean, I guess I could rush it, but I don't want to rush it, right? The point is for you to learn the concept. All right, so anyway, any questions about that before I leave? I get so scared when I leave. I'm not going to erase this, but I'm in that mindset of this problem. Any questions about this Picapia problem? It's a great one, right? B was negative. So if you can do this problem, if you can do a problem like this, I hope you can do the previous ones, right? But I'll go back if you need to. Okay, remember, I'm willing to stay until 10:30. I don't think I have to go tonight. All right. Okay, let's see, 464. All right. Oh, okay, yeah, there's a question about Was it an undefined problem on force 7? Yeah, kind of going back and forth in the chat here. Force 7 had some undefined ones. I think someone was asking about undefined. And basically, it's a matter of kind of working it out, right? Yeah. Okay, so especially number 5? Number 5, right? Okay, so for example, here, we take inverse sines of sine values. Is 1/2 a sine value? Yes, it is. That's good. I'll put a little check mark here. That's good. 1/2 is a sine value. That's good. -√3/2, that's a sine value. In fact, these are both famous sine values. That's good. These are both values between -1 and 1. So we're going to get an answer, which you probably think of as an angle. Here's a tricky one. I know that sine of pi/2 is 1, but what's inverse sine of pi/2? What is this about? Pi is about 3.1, 3.2. So pi/2, okay, pi/2 is somewhere between 1.5 and 1.6. It's 1.5 something. Wait a minute. Is 1.5 a sine value? No, it's not. Pi/2 is not a sine value. Here's the problem. I'll put this in red. Pi/2 is about 1.5 all right? Not a sine value. In fact, I could type that. There's also the keyboard. I feel like a musician. Trackpad, keyboard, mouse, tablet. Not a sine value. This thing's undefined. All right. That's a cosine value. This is defined. That's a tangent value. In fact, that can be -1,000,000. That's still a tangent value. So of the first 5, C is the only one that's undefined of the first 5. And it's a trick question because sine of pi/2 is fine. That's 1. But inverse sine of pi/2, that's no good. That's undefined. So C is the only undefined one of the first 5. And I can do these in more detail if you wish. 2/7 goes to sine. Asks, am I in your range? Yes, you are. Answer is 2/7. Now, -2 as cosine, am I in your range? Nope. So then we ask, what's up? Can we take the inverse cosine of -2? Is -2 a cosine value? No, it's not. G is bad. G is undefined. So was C. C was undefined. G is undefined. But -2 asks tangent, hey, am I in your range? Tangent says, yeah, I'm liberal. Every real number's in my range. We're good. We're defined. We're not undefined. Here, sine of pi/5, that's legit. Pi/5 asks inverse sine, am I in your range? Yes, you are. Pi/5. That's good. Okay, now here, 7 pi/6 asks inverse cosine, am I in your range? The answer is no. But here's the thing. This is real. It is defined, but the answer is not 7 pi/6. Okay, because cosine of 7 pi/6, that's cool, right? We don't have a domain problem here. The problem is that it's a range issue, the fact that 7 pi/6 isn't a range. This does give you a real value, like an angle, but it's not going to be 7 pi/6. It's going to be some brother. Over here, we just answered this. The answer was -pi/3, right? I never checked the answer for that. Right, -pi/3, right. And the only ones that were undefined here were G and C, right? C and G were the only ones that were undefined. So step by step. So here, right. So here, if this guy's not in this guy's range, you're dead, undefined. Now, for a problem like, and then here again, you're dead. Now, J was more subtle because it's true that 7 pi/6 isn't this guy's range, but the thing is, cosine of 7 pi/6 is a good cosine value. So yeah, these guys here, they're the weirdest. I, J, and K are the hardest ones. Yeah, because it's more subtle. As the late Johnny Cochran might have said, when in doubt, work it out. See what happens. Yeah, you're very welcome. Yes, I know these are confusing. I have to think about it too. Okay, what am I missing here? 464, 47. So yeah, 476. Right. So the right triangle ones. Okay. So I'll make a deal with you. I'll do 6A, and then I'll give you a hint on B, and then see if you can work it out and get to me later tonight. Okay. So first of all, my hint on B. You can think of X as X over 1. Okay. And then once I do 6A, hopefully this hint will help you do B. Let me know if you can get it. Let me work out 6A. I'm sure many students had questions about this. Worthy of a new sheet. All right. It's funny. I don't have the pre-recorded video, so my throat gets drier now. I'm still doing fine, but yeah, it's not like the pre-recorded videos where I can save my voice. Okay, 6A. It's 4-7, yeah. So actually, a tablet. Right. But yeah, red is kind of a triggering color, so let's avoid that. I think blue is kind of a nice non-triggering color. There are actually educators who say that we shouldn't grade with red pen because it's triggering. I don't know if that's too far, but I don't like green. So, okay, let's see this over here. Okay, so a common trick is to let this be like an angle. So I'm gonna let this be theta. All right, let theta be this. Okay, so actually I'll write it like this. Let inverse sine of x over 5 be theta. Of course, you can write it the other way around where you switch the sides here, okay? But the thing is, I think the zigzag might be more apparent in this form, right? I want to go from an inverse sine statement to a sine statement. So what do? I switch inputs and outputs. I switch inputs and outputs. If the inverse sine of x over 5 equals theta, what's true? Now these are getting in the way, so what's true? The sine of what is what? The sine of theta now is x over 5. And now I can use the ideas of Sohcahtoa, the ancient curse, and a right triangle model. And remember that it's okay to assume that theta is acute. We get very lucky that we have the right to assume that theta is acute, and it turns out that the procedure will work, even for more general theta. All right, let's Sohcahtoa this. Model right triangle. I'll put theta here. Although if you wish, you could put theta there. If you put theta there, though, please model it, because otherwise I kind of assume that theta is here. Either way, you should label which complementary angle is theta, which acute angle is theta. All right, Sohcahtoa. Let's model a triangle so that this is true. Sine, so SOH, sine is opposite over hypotenuse. Opposite over hypotenuse. Let's put the x here and the 5 here. And this is probably the simplest triangle for which that's true. Now, it's also true that you can put x over 5 here and 1 here, but I think that's going to lead to a harder expression. So although that's legal, I wouldn't recommend it. I think this is easier. X here, 5 here. Sohcahtoa, sine of theta is x over 5. But in the end, I want tangent of theta. In the end, what do I want? Aside from peace in the world, right? We want, ultimately, tangent of theta. Tangent of this ugly thing here that we're calling theta. All right. Sohcahtoa, tangent is opposite over adjacent. That's A for opposite, not 0. Ooh, but that means I need this side length here, B. I got to find B. And whose theorem will let me do that? Mr. Pythagoras. All right. I'll do this in brown. All right. Mr. Pythagoras says x squared plus b squared equals 5 squared. The square of the hypotenuse equals the sum of the squares of the other two sides. We're not going to mess it up like in The Wizard of Oz. That was horrible. This is 25, of course. I'll do this to save space. That's 25. All right. Now we're solving for b, remember. We're solving for b. So I'm going to start by solving for b squared. Subtract x squared from both sides. You don't have to write this down, but a lot of students like this. So then that cancels out the x squared terms up here. We're left with b squared on the left side equals 5 squared is 25. We still have the minus x squared. We subtracted x squared from both sides. B equals, technically we start with plus or minus the square root of 25 minus x squared. But this right triangle procedure, we're allowed to get rid of this. Remember, we're assuming that we're allowed to assume that theta is acute anyway for the purpose of finding the final expression. And it does turn out to work more generally. So that's B. That's B. So what's what we want? Tangent of theta. That's the guy we actually want. I'll do this in red finally. Tangent of theta equals opposite over adjacent. I'm sorry. I'm so used to sine. Tangent is opposite over adjacent. It's x over b. X over b. All right. Which turns out to be, well, x on top. B is that guy. Extend the radical as appropriate. X over root 25 minus x squared. I'll accept this as the final answer because if you have a variable radicand, we tend not to rationalize the denominator. So if anything, we tend to prefer this. I know that's a bit different from what I say in the notes, but actually we prefer this. So this is considered more simplified. X over root 25 minus x squared. Am I right? Yes, I am. X over root 25 minus x squared. Again, I kind of tried to rationalize the denominator here, but that works only if x is rational, right? So actually, this is considered more simplified, the one on the left. Hey, by the way, is that 5 minus x? Can I take square roots term by term? Answer is no. Otherwise, I would have done that. You cannot take square roots term by term. Now, you can take them factor by factor if the pieces are non-negative, but you do not take square roots term by term. Root 25 minus x squared, that does not simplify nicely. If you think you can simplify it nicely, you don't know what you're doing. All right. So that's the answer. Right. And then part B, it's a very similar process. When you construct your triangle, what's the proportion? Think x over 1. Sometimes students get confused because they go, well, where's the proportion? What do I do? What over what, right? Think of x as x over 1. I'm not being patronizing. I mean, that's the key insight. If you understand how to do 6a, the insight on B is that x can be written as x over 1. Don't forget that. All right. Any other questions about that before I leave here? Right? This is a whole process, and you are going to do this in Calc 2. That's a promise. Okay, unless you drop it or something. I hope you don't. But in Calc 2, you are going to use these kinds of techniques. When you do integration with trig substitutions, you are going to do this. You're gonna simplify guys like these. And don't forget, I want to remind you, you can check on Desmos. It's not a proof, but you can check on Desmos. I love doing this, showing that these guys are equivalent, because it's so shocking, right? Just quickly, Desmos.com. Tangent of arcsine of x over 5. That guy there. Let's try, I didn't need the y equals, but, and then let's try this guy. X over root 25 minus x squared. Square root 25 minus x squared. Look at that. Same graph. Not a proof, but I'm feeling really good about this. Isn't that amazing? This and this, they're equivalent. They even have the same domains. The open interval from -5 to 5. It's amazing. Okay, and obviously if you have the chance, you prefer the algebraic form, right? Okay, anyway, let's continue with chat. Okay, yeah, 476AB. Okay, and then 4217. By the way, as you've seen, questions I do in class, they may be especially likely to be the ones to be graded, right? Because I have some video to point to. I have an incentive to have at least some of the problems I grade be the ones that we talk about in class or after class. Okay, 4.2 number 17. Lots of good reasons to come to class. I'm recording, right? Yes. I would cry if I weren't recording. Okay. You hear a teacher go, wah. Okay, 4.2.17. Ah, yes, yes. Great concept problems. Using symmetry on the unit circle. Let's talk about this. All right. Let's go to blue. All right. So consider the unit circle. All right. That's actually a pretty good circle. Which one of the following is right? Okay, so I'm basically asking you to compare tangent of pi minus theta and tangent of theta. Okay, if you're desperate, look at that. Although here, it looks like I'm trying to hint at a cofunction identity. I know this would work if we had pi over 2 there. Then I know that this would be a cofunction identity. Without that, I'm very skeptical. So I don't think it's going to be 3. Okay, this looks like a perversion of the cofunction identities. Okay, now over here, let's compare these guys. Now, let's assume for now that theta is acute. So let's say that this point corresponds to the angle theta. Now, if that's the case, where would pi minus theta be? What quadrant would pi minus theta be? It would be in quadrant 2. Again, let's assume for now theta is acute. Quadrant 1, all right. Pi minus theta is that backtrack. It's like you're going pi radians minus that acute angle, that reference angle. You're over here. Okay, now, when I think tangent, I think what concept? Slope. Compare slopes. Compare the slopes of these two blue radii, these two blue line segments here. This here and this here. Are the slopes going to be equal or opposites? It looks like they're going to be opposites, right? Because it looks like the slope here is going to be positive. The tangent of this acute angle is positive, but the tangent of a quadrant 2 angle is negative. So I think the tangent values are opposites. The slope for the pi minus theta angle, this guy here, this guy is pi minus theta. This guy is pi minus theta. The tangent value is negative. In particular, it's the opposite of this. So for example, if the tangent of theta is 2, the tangent of pi minus theta will be negative 2. These values are going to be opposites of one another. I think it's going to be this here. And then in chapter 5, using the special identities, you can prove this using the difference identity for tangent. So the answer to 17 is Roman numeral 2. Okay, sorry for making you dizzy. Yep, 2. But it's good to see why. Like I said, you don't have to show work, but just for your benefit, if you want to look back on this homework, right, then it's good to do little pictures like that. So remember, you want to make a good binder of homework where even if I don't grade them explicitly, you want good notes for yourself, right? It's a pre-calculus class. Train yourself for calculus. All right. Any questions before I go on? And the others are similar. 16 is similar in flavor, right? 16 is similar in flavor, and so is 18. It's just different trig functions and different comparisons, like here. Yeah. All right. 483. All right. So word problem here. All right. Okay, very appropriate because it's quite possible I may grade a word problem, right? Good to have the video up. All right, so let's get a new all right. By the way, after this, I'm going to do number 3 here, and then I'm going to take a 5-minute break. I got to get a glass of water, so I'll do this, and I'll get a glass of water. Come back at 9:35, maybe. Okay. So number 3, 4-8, number 3. Oops. All right. 4.8, number 3. All right. A balloon in the air is tied by a straight 23-meter wire. I say that because there's no slack. It's not curvy like this. It's not curvy like that. It's straight. And it's a hypotenuse. It's the hypotenuse. It's not the altitude or height. It's the hypotenuse. Here's a balloon. It's good to write this out. Spike. The spike, the nail, is over here. Triangle basically looks like that on the ground, which is flat. So the ground's flat, it's not an incline. All right, so it's a right angle here. All right. A. I guess different pictures for the different parts. So for A, at a particular time, the angle of elevation to the balloon is 18 degrees. That's this angle here. All right. Actually, it's flatter than that, but don't worry. I'm not going to get a protractor. I'm not going to measure angles, right? 18 degrees. What is the height of the balloon from the ground at that time? All right. Now remember, the 23 meters is the length of the wire. This is the actual wire. It's this thing here. So this here is the 23 meters. And that surprises people. That's what gets people. The 23 meters is here, not here. We want to find the height. We want to find the height. That's X or H here. All right. So what do we know? What do we have to find? We know this angle's 18 degrees. We want to find the opposite side. We're given the hypotenuse. Although that took some thought. What relates? Angle, opposite side, and hypotenuse. Once again, our old friend sine. Or cosecant. Let's go with sine for now. Sine of 18 degrees is, is H over 23. Our answer will be in meters. All right. In fact, I even put the unit here, right? Multiply both sides by 23 meters. So we get H equals, bottom line, 23 sine of 18 degrees meters. Okay, and that should give you the answer. $7.11 meters. And then technically you should write a sentence, right? The height of the, the height of the balloon is about 7.11 meters. I encourage you to write that. We're supposed to. The height of the balloon is about 7.1 meters. All right, so that's part A, and that is that, right? I should get Wolfram Alpha, the freebie. Yeah, what's I'm looking for an online calculator. 23 times sine of 18 degrees. Degrees? Does that work? Yeah, about 7.11. Right. So, hey, if you want a quick online calculator, Wolfram Alpha, and then you can pay for some other stuff. Yeah, all right. Maybe I shouldn't have shown you that, but if you want some quick calculations, there you go. All right. Let's see here. Okay, in part B, I'll set this up. So on part B, why don't I set this up and then see if you can do the computations. So for part B, an hour later, the wind changes. We have a different situation. The balloon is now 10 meters high. It's going to be higher. It's going to be higher than this. So I think the angle here is going to be bigger, okay, using our sense. Not to scale here necessarily, but looks like New Hampshire. The angle is going to be different. It's no longer going to be 18 degrees. Balloon is now 10 meters high. That's 10 meters. That's supposed to be vertical. What's the angle of elevation to the balloon? But see, the constant is that it's still a 23-meter wire, right? The hypotenuse is still 23 meters. Okay. What relates angle? Opposite side hypotenuse. Again, sine, but this time you're going to punch what button on your calculator? You're going to punch inverse sine, right? That's a key hint. You're going to be using inverse sine. In fact, I may as well say it. Theta is going to be inverse sine of 10 over 23. And does this do that? Arc sine of 10 over 23? Well, it just showed me it, right? Yeah, about 0.44 degree, but I want that in degrees. Oh, it converts. Yeah, Wolfram Alpha is too powerful. About 25.8 degrees. Yep. So use Wolfram Alpha sparingly. Angle of elevation is about 25.8 degrees. You don't have to write that out. You can put the degree symbol. All right. Okay, so it's we're approaching 9:33. Allow me to get a drink of water. I'm going to come back at 9:38. Of course, you can go at any time. I'm not taking attendance. I am keeping track of who's participating, but I'll be back at 9:38. 9:38, and I'll continue. All right, I got to get a drink of water. Let's pause and record and mute. Okay. So some of you, I'll see you soon. We'll continue. Zoom. Okay, please remind me to record because we want to get this on the recording. All right. We've done 4.83 A and B. And again, the word problems definitely show work like this. Yep, show work, definitely. So like I said, as far as work goes, for 8, show work. For 7, number 7 on these, I'd like you to show some work. All right. Show your thought process, like in the notes, maybe with the unit circles, symmetries, computations, maybe what you're doing. Right. All right. Anyway, let's go down the list. So we did 484. This is 483. Right, 483. A couple of people wanted 483. People were having trouble with that. We did 46. We did a problem. 47, number 3. Have we done that? 47. Oh, okay. Graphing the inverse tangent function. Right. Okay, so in fact, I'll refer to my notes. Let's see here. refer to my notes. Math 141. Yeah. Okay. So the graph of the inverse tangent. Here's the story. Okay. So in the beginning, we have this graph of snakes. Okay. But we need a piece that passes the HLT. We want the same range as the overall. I still want the range to be all real numbers, like for tangent overall, but I only want a piece of the graph that passes the HLT. It's natural to take this snake here that goes to the origin. All right. Notice we have VAs at x equals negative pi over 2 and x equals pi over 2. The VAs become what when we invert? The VAs become HAs. Now, if the original function is increasing, the inverse of an increasing function is still increasing, okay? Because x and y are still going together. As one increases, so does the other, all right? This guy is odd. This guy's also odd. The inverse of an odd function is odd. We tend not to take inverses of even functions because those graphs tend to fail the HLT. All right, so we have this rising lazy snake that also goes to the origin, all right? We have HAs here at y equals negative pi over 2 and y equals pi over 2. Of the graphs for inverse sine, inverse cosine, and inverse tangent, the inverse tangent graph is the only one with infinite arc length. The other two have finite arc length, okay? Look at this. Here's the graph for inverse sine. These are tangent lines, not arrows, okay? Finite arc length. Inverse cosine. This guy, finite arc length. Inverse tangent is the only one of the basic three inverse trig graphs with infinite arc length. It goes on forever and ever, to the right and to the left. But that's the graph. All right. That's 473, and then 477A. Yeah, okay. So it's good to have a combination of unit circle and some work. It's good to do one of these, all right? Let's begin with sine of theta equals 0.3. Let's solve that. Good for the tablet. All right, so let's solve this one over here. Solve sine of theta equals 0.3. I'll use radian. Well, let's see. What do I want to use here? Maybe radian. I'll use radians for now. All right, let's consider the unit circle. 0.3 is a legitimate sine value, right? It's not like 3 or 4. 0.3 is a legitimate sine value. It's positive. In what two quadrants is the sine value positive? The y-coordinate positive? Quadrant 1 and quadrant 2. Corresponding to, whoops, it's kind of a flatter guy. This guy here, and his partner, this guy here. All right, now this guy here, I can obtain by taking the inverse sine, or arc sine, of 0.3. And what is that in radians? I'm doing this to, what, 4 sig figs? So I'll go to Wolfram Alpha again. Again, use sparingly. You got to show work on stuff. That's a nice tool, though. Inverse sine of 0.3, arc sine of 0.3. 0.3047. It's okay to use the answer as a guide. Yeah. 0.3047. You don't need the 0, but 0.3047, right? Yeah, 0.3047. Okay, now that's the acute angle here. That's the acute angle. From here to here, that's about 0.3047. Now question, how do I get to quadrant 2, right? So I'll kind of blow this up. How do I get from this guy to his brother over here, All right. What's a half revolution? A half revolution is going to be pi. But wait a minute, I'm going to backtrack by the reference angle, which is given by this acute angle over here in radians. Pi minus 0.3047. Okay, so what is that? Well, I can just go pi minus this, right? Pi minus that, 2.837. 2.837. Yep. Okay, find the two solutions. Okay, so if you list them out, I'm fine. Although technically, for a solve an equation problem, it's ideal to use a solution set form. They don't even have to be in order, but about 0.3047 and about 2.837. Although, folks, if you've done the homework already, you don't need the braces, but in Chapter 5, it's good to get in the habit of using braces when you're solving an equation. Okay, but here, if you at least box them in or something, box them in, there are two solutions, right? There are two angles. There are two angles between 0 and 2 pi radians whose sine value is 0.3, and here they are. Okay, at the very least, box them in. And sometimes the reference angle is an answer, sometimes it's not. Right, here the reference angle is an answer. Part B is a little trickier because the reference angle is not going to be an answer, right? This is the reference angle also for the solutions you get here, but the 0.3047 itself will not be a solution. Neither will this guy, because these are angles whose sine value is positive 0.3. Here in B, you're going to want angles whose sine value is negative 0.3. They're going to have this as a reference angle, but this itself would not be a solution. Okay, for degrees, well, the thinking is very similar, right? So there you would want this in degrees. So Wolfram alpha, it already has arc sine of 0.3. It shows you the radian measure, and it already does the degree. Does it do the degree? If not, I know that the conversion is times 180 over pi. But normally calculators would have the would allow you to convert to degrees. It's 17.46 degrees. Yeah. But a calculator, it's just a matter of putting this in degree mode. This turns out to be about, I'll do this in green. Wait, hold on. That's in blue. This is in green. All right. In degrees, it'll be about 17.46 degrees. And then how do you get the brother in quadrant 2? Okay, so in degrees, how do you get the brother? So here is 17.46 degrees, about. How do you get his brother over here? When you do a half revolution, that's pi radians. Pi radians is how many degrees? Pi radians is a flip-flop 180 degrees. Subtract off the reference angle because we're going, right? 180 degrees, and you're subtracting off the reference angle. You're backtracking the 17.46. Or 80 degrees minus 17.46 degrees is about 162.54 degrees or 162.5 degrees. Yeah. It was right there. 162.5 degrees. Okay. To 4 sig figs, about 17.46 degrees and about 162.5 degrees. Again, it might be ideal to put the braces there. In either case, make it clear that these are the two solutions in degrees. Okay. again, the reference angle here is a solution. Bear in mind, for part B, that won't be the case, because the 17.46 degrees will be the reference angle for the solutions here, but this itself will not be a solution for part B. For part A, it is, but not for part B. All right. Yes, you're welcome. Let's see. So I think I've cleared the chat, I think. Is there anything else right now? Again, I have been recording this, or if you want me to pause the recording, I can do that also. I think I've cleared the chat. Have I missed anything? Or are there any additional questions? Thank you for your perseverance and hard work. It's 9:50. I'm still available, but I know you've had a long night. So thank you to your hard work. Any questions? Thank you. Any questions? Any questions? Okay, we're approaching 9:51. Again, for some of you, good night. I'll be back at 9:55 p.m. Okay, so once again, I'll mute and record. Oh, okay, so mute, record, back at 9:55 p.m. So for some of you, good night, good luck. Okay. Otherwise, I'll be back at 9:55 p.m. to see if anyone has further questions.